The adverse effects chemical substances may have on the human body necessitate the use of protective clothing. The predominant physical, chemical, or toxic property of the material dictates the type and degree of protection required. For example, protection against a corrosive compound is different than that for a compound which releases a highly toxic vapor. The work function and the probability of exposure to the substance must also be considered when specifying protective clothing. As with the selection of proper respiratory protective apparatus, the hazards encountered must be thoroughly assessed before deciding on protective clothing to be worn. Once the specific hazard has been identified, the appropriate clothing can be selected. Several factors must be considered, most important being the safety of the individual. The level of protection assigned must match the hazard confronted. Other factors include cost, availability, compatibility with other equipment, suitability, and performance. Protective clothing ensembles range from safety glasses, hard hats, and safety shoes to fully encapsulating suits with a supplied source of breathing air. The variety of clothing includes disposable coveralls, fire retardant clothing, and chemical splash suits. Different materials are used to provide a protective barrier against the hazard. Protective clothing protects primarily because of the material from which it is made. In selecting the protective material, the following should be considered. Chemical resistance, which is the most important. When clothing contacts a hazardous material, it must maintain its structural integrity and protective qualities. Strength, which is based on resistance to tears, punctures, and abrasions, as well as tensile strength. Flexibility, which helps make it easy to move and work in protective clothing. Flexibility is especially important in glove materials. Thermal limits affect the ability of the clothing to maintain its protective capacity in temperature extremes. Thermal limits also affect mobility in cold weather and transfer of heat to the wearer in hot weather. Cleanability, which can be difficult and expensive if protective clothing is not cleanable. Some materials are nearly impossible to clean adequately under any circumstances, hence disposable clothing is sometimes used. Lifespan, which is the ability to resist aging, especially in severe conditions, over time. This should be balanced against the initial cost of the garment. Chemical resistance. Protective material must be able to resist degradation, penetration, and permeation by the contaminant. Any of all these actions may result upon contact, depending on factors such as concentration and contact time. Degradation. Degradation is the result of a chemical reaction between the contaminant and the protective material. Damage to the material may be slight or as severe as complete deterioration. The reaction may cause the material to shrink or swell, become brittle or very soft, or completely change its chemical and physical structure. Changes such as these may enhance or restrict permeation or allow penetration by the contaminant. Penetrability. A chemical penetrates a protective garment because of its design and construction imperfections, not because of the inherent material from which it is made. Stitched seams, buttonholes, porous fabric, and zippers can provide an avenue for the contaminant to penetrate the garment. A well-designed and constructed protective suit with self-sealing zippers and lapped seams made of a non-porous degradation-resistant material prevents penetration, but as soon as the suit is ripped or punctured, it loses its ability to prevent penetration. A material may also be easily penetrated once degraded. Permeability. The ability of a protective material to resist permeation is an inherent property. A contaminant in contact with the protective material establishes a concentration gradient. When the contaminant passes through the material to the inside surface, it condenses there. The process of permeation continues as long as the concentration remains greater at the contact surface. The permeation rate is based on several factors. Rate is inversely proportional to the thickness of the material and directly proportional to the concentration of the contaminant. The amount or degree of permeation is related to the exposure conditions, especially contact time, which ultimately dictates how much of the contaminant permeates the protective material. Thus, a conscious effort should be made to avoid prolonged exposure or contact with any hazardous contaminant, even when wearing protective clothing. No material resists permeation by all agents. Decontamination. Once a contaminant contacts a protective material, the garment must be decontaminated. With any materials, it is impossible to completely remove all contamination. In some situations, disposable clothing may be advantageous. Protecting workers in hot environments. Many workers spend some part of their working day in a hot environment. Workers in foundries, laundries, construction projects, and bakeries, to name a few industries, often face hot conditions which pose special hazards to safety and health. Heat stress causes body reactions. 4 environmental factors affect the amount of stress a worker faces in a hot work area: temperature, humidity, radiant heat, such as from the sun or a furnace, and air velocity. Perhaps most important to the level of stress an individual faces are personal characteristics such as age, weight, fitness, medical condition, and acclimatization to the heat. The body reacts to high external temperature by circulating blood to the skin, which increases skin temperature and allows the body to give off its excess heat through the skin. However, if the muscles are being used for physical labor, less blood is available to flow to the skin and release the heat. Sweating is another means the body uses to maintain a stable internal body temperature in the face of heat. However, sweating is effective only if the humidity level is low enough to permit evaporation and if the fluids and salts lost are adequately replaced. Of course, there are many steps a person might choose to take to reduce the risk of heat stress, such as moving to a cooler place, reducing the work pace or load, or removing or loosening some clothing. If the body cannot dispose of excess heat, it will store it. When this happens, the body's core temperature rises and the heart rate increases. As the body continues to store heat, the individual begins to lose concentration and has difficulty focusing on a task, may become irritable or sick, and often loses the desire to drink. The next stage is most often fainting, and then possible death if the person is not removed from the heat stress. It is evident that protective materials are available for specific chemical contaminants, but there is no one material which provides protection against all types of contaminants. Thus, several layers of protection should be considered when more than one contaminant is present or the hazards are unknown. Disposable boots, gloves, and splash suits are another way to provide an extra layer of protection. Types of protective clothing. The selection of appropriate protective gear is based on the hazards anticipated or recognized. Complete protection calls for assembling a set of gear including hard hat, safety glasses or face shield, preferably both, body covering, coveralls or pants and jacket, gloves and safety shoes, steel toe and shank. Omitting one item may compromise the individual's safety. Some pieces of protective equipment, such as hard hats and boots, have specific standards for manufacture, and only those items meeting these standards should be used. Selection must be based upon judgment. Limitations and problems. Each type of protective clothing has a specific purpose as well as limitations. The following are common problems associated with the use of protective clothing. No clothing is resistant to all chemicals. Workers have decreased manual dexterity and/or mobility. Vision is often impaired. Heat stress may result from the prevention of normal heat exchange mechanisms. Know the hazard, then select the proper protective equipment.